All right, so today we're taking a deep dive into something pretty fascinating. We're talking about polymer upcycling, turning that plastic waste into valuable materials.
Yeah, and you know what's really exciting is that we're moving beyond. We're not just talking about like melting down old plastic bottles into something slightly less useful. We're talking about really transforming plastic waste at a molecular level, creating these entirely new materials that actually have better properties than what we started with.
Yeah, that's exactly what kind of got me hooked in cocktail party chemistry. In episode 83, polymer upcycling, transforming plastic waste. They were talking about catalytic depolymerization, and I was like, wait a minute. So we're breaking plastics down and then building them back up, but into something completely different.
Yeah, that's the idea. So imagine you have this giant Lego structure, but you want to build something totally new, right? You want to create something else. So depolymerization is like carefully taking apart those Legos, breaking the plastic down into those basic building blocks. And then we can take those blocks and reassemble them, kind of like Legos, and create what we call specialty polymers.
Okay, specialty polymers.
Mhm.
So what makes them so special?
Well, think of them as polymers with superpowers. These upcycled polymers are designed for specific purposes, and they often have enhanced mechanical properties compared to their original forms. So we're talking about things like strength and their ability being much better. For example, imagine a flimsy plastic bottle, right? Like something you just toss in the recycling bin. That could be transformed into a high-performance material that's used in car parts, or even in airplanes.
Wait, so you're saying my next flight could be on a plane partly made from recycled plastic bottles?
hmm
It's kind of mind-blowing. But I'm thinking, this whole process, it sounds pretty energy intensive. How does it actually compare to traditional recycling?
Well, that's where things get really interesting, because some of these cutting-edge upcycling methods actually use less energy than traditional recycling.
Wow, so less energy consumption and we're getting higher value products? I mean, that's a win-win from both the environment and the economy, right?
Absolutely. This kind of approach really embodies those principles of green chemistry. It's not just about reducing harm, but it's about designing processes that are inherently more sustainable. And the economic benefits are pretty significant.
Hmm.
We're talking about transforming what was once considered waste into a valuable commodity. We're creating new markets, and we're driving innovation within the chemical industry.
This is starting to sound less like waste management and more like a treasure hunt. Like we're finding this hidden value in something we used to just throw away.
This episode of Cocktail Party Chemistry, it really highlights how upcycling processes can convert mixed plastics into these specialty polymers that we're talking about. Exactly. It's all about seeing opportunity where others see only trash. And that shift in perspective, that's really what's fueling this exciting new era of polymer upcycling.
So we're not just talking about recycling anymore. We're talking about like upgrading. But I'm curious, how does this upcycling magic actually happen? What are some of the techniques that scientists are using to break down and rebuild these plastics?
So there are a few key approaches, and they all kind of revolve around that idea of depolymerization that we were talking about earlier. One method involves using heat to break down the plastic, and that's called thermal depolymerization. Another one uses specific chemicals, and we call that chemical depolymerization. And there's even a method using enzymes, which is kind of inspired by nature's own recycling processes.
Enzymes,
Yeah.
like the stuff that helps us digest food. That's wild. So it sounds like, depending on the type of plastic and what you're trying to make, scientists can choose the best method for the job.
Exactly. It's like having a whole toolkit for transforming this plastic waste. And what's great is that these methods allow us to create this wide range of specialty polymers with really tailored properties. We can create polymers that are exceptionally strong and lightweight, which would be perfect for things like the automotive or aerospace industries.
I'm thinking back to that example of a plastic bottle becoming part of an airplane. It's incredible to think that something we just toss in the recycling bin could have a second life like that. But let's be realistic. I mean, there have to be some challenges to making this work on a large scale, right?
Oh, you're absolutely right. One of the biggest hurdles is scaling up these technologies. What works perfectly in a lab setting
Mhm.
doesn't always translate smoothly to industrial scale production. We need to develop more efficient and cost-effective ways to do this, to depolymerize and repolymerize these plastics, but on a massive scale.
So it's kind of like baking a cake.
Yeah.
A recipe might work great for a small batch, but when you're trying to bake for 100 people, you might need to make some adjustments.
Exactly. Another challenge is sorting and collecting different types of plastics, because a lot of these upcycling methods require specific types of plastic to work effectively. So, for example, a process that's optimized for paid plastic from bottles might not work as well for a different type of plastic, like, say, polypropylene.
That makes sense.
Yeah.
So even though we're all diligently sorting our recyclables at home, there's still a need for even more advanced sorting technologies to separate the plastics further down the line. Otherwise, we just end up with a mixed bag of plastics. And they might not be suitable for these specialized upcycling processes.
Exactly. And there's another aspect to this too, consumer perception. Some people might be hesitant to embrace products that are made from upcycled plastics. Maybe they have concerns about the quality or the durability or even the safety of these materials.
Yeah, it's like that old saying, one man's trash is another man's treasure. But convincing everyone to see that treasure, well, that takes time and education.
Absolutely. We need to raise awareness about the potential of these upcycled materials and show people that they can be just as good, if not better, than products that are made from virgin plastics.
So it sounds like we're kind of on the verge of this materials revolution. But there's still some work to be done to make it a reality. It's not just about the technology itself. It's
Yeah.
also about the infrastructure and about changing people's mindsets.
Yeah, I
But,
think that's a great way to put it. Polymer upcycling isn't a silver bullet solution, but it's definitely a crucial piece of the puzzle. When it comes to solving this plastic waste crisis that we have, it offers a more sustainable and circular approach to how we produce and use plastics.
okay, so we've talked about the how and the why of polymer upcycling, and we've touched upon some of the hurdles. But what about the future? What possibilities does this technology unlock? And what kind of impact could it have on our world? I mean, it really feels like we're on the cusp of something big here. Like if we can turn plastic bottles into car parts and airplane components, I mean, what other kinds of transformations are possible? What's the ultimate potential here?
I know, right? The possibilities are pretty much endless. I mean, imagine a future where plastic waste isn't seen as a problem anymore, but as a valuable resource. We could be creating these high-performance materials from recycled plastics, which would mean we're less reliant on fossil fuels, and we're minimizing that environmental impact of plastic production.
So we're not just cleaning up the planet, we're kind of unlocking this whole new era of material science. So where do you see polymer upcycling making the biggest impact in the coming years?
Well, one area that's really promising is the development of advanced textiles. So think about clothing, carpets, fabrics, all made from recycled plastic bottles. And these upcycled textiles, they can be engineered to have specific properties, like water resistance or breathability or durability, and they can actually rival or even surpass traditional materials.
That's incredible. That could completely change the fashion industry, which is known for not being very environmentally friendly. But I'm guessing these advanced materials could be used for way more than just clothing, right?
Oh, absolutely. We're talking medical devices, construction materials, packaging. The possibilities are really endless. We could create biocompatible plastics for things like implants, super strong composites for buildings, even biodegradable packaging that breaks down safely in the environment.
It's like we're changing the rules of the game for plastics.
Hmm.
This material that everyone thinks of as pollution and waste. We're turning it into something that's innovative and sustainable.
Exactly. That's really the whole point of polymer upcycling. It's a complete paradigm shift. We're moving away from that linear take, make, dispose model and moving towards this circular economy where materials are constantly being reused and repurposed. So we're minimizing waste and maximizing resource efficiency.
This deep dive has been really eye-opening. It's so inspiring to see how science and innovation can tackle these environmental challenges and help create a more sustainable future for everyone. But it's clear that it's going to take all of us to make this happen.
I agree. As consumers, we can choose to support companies that are investing in these technologies. We can advocate for policies that encourage these innovations. And of course, we can all do our part to reduce our own plastic consumption and choose reusable alternatives whenever possible.
It's a team effort for sure. From scientists to businesses to policymakers to everyday people. We can all help make polymer upcycling a reality and build that more sustainable future.
Definitely. It's a future worth fighting for, one where plastic waste is a valuable resource, unlocking all kinds of possibilities for innovation and a healthier planet for everyone.
Couldn't have said it better myself. So to all our listeners out there, keep those minds curious. Dig deeper into the world of polymer upcycling. Explore what's happening in your own communities, and just imagine the possibilities. Thanks for joining us on this deep dive.